We are going to start off this part of this week's video with summation notation. This really is only if you're not familiar with how it works. We use summation notation in quite a few of the formulas in statistics, so I thought it might be useful just to kind of go over what it means and how to use it. So we're going to assume that we have a sample of size n, and we have data for one variable for each member of that sample. So for example, if we have a sample of size 5 and the variable we're looking at is number of pairs of shoes owned, and we have a list of data, 4, 15, 20, 22, 15. So we want a generic way to be able to refer to data values. We assign a x with a subscript to each of those data values. And that means we're going to have x subscript 1, x subscript 2, etc., all the way up to x subscript n. If we want to look at a single data value generically, we'll just go x sub I, where that I is the index value. You can think of that I as being the value that changes as we go from one data value to the next. Okay, that subscript has no bearing meaning whatsoever, only to distinguish it from another data value. Just to let you know that x sub 1 is going to be a different value from x sub 5. So if we use this notation to pair up this notation with the data values, we could say x sub 1 is equal to 4, x sub 2 is equal to 15, x sub 3 is equal to 20, x sub 4 is equal to 22, x sub 5 is equal to 15. All right, as you can see, those subscripts don't have any meaning based on the size. It really is just kind of the order that they're listed. So we can just generically then use this notation to refer to a set of data values, x sub 1 up to x sub n. Okay, now we want to add together or sum up the data values. Well, when we only have the 4 or 5 data values, or a small number, it's pretty easy just to say, oh, we're just going to add them up and use addition symbol to do that. Most of the time we don't have that small of a sample size. So we want to represent summation in a more concise way, a way that doesn't take up so much space. So we have summation notation. It's a shorthand way to represent the adding up or summing of data values. So the symbol that we use to stand for summation is a Greek letter. It is the Greek letter sigma that looks like that, and it's actually the uppercase Greek letter sigma. So here, I'll write it again down here, and that tells us we're going to sum. We have to then also include in the notation what we want to sum up. In this case, we want to sum up the x sub i's. All right, so there's a subscript of I on that x. Now we want to tell it, well, what values of I? So at the bottom of the sigma, we say we want I to start with the first one. So we want it to start with 1. And we want to go up to the last one, which is n. Okay, so that's that's the summation notation. I'm going to write it down here where I have a little more space and I can be a little more clear in what that is looking like. So we've got the x sub i's, and down below we say I is going to start with 1 and it's going to go up to n. All right, that equals x sub 1 plus x sub 2 plus x sub 3 plus all the way up to the last data value, x sub n. Oops, sorry about that. Let's do the summation notation indicated by each of these summations. So this first one we already kind of looked at and wrote out, but this is going to be the sum of the x's. Now you'll notice it doesn't have the I equals 1 to n on it. Usually that's just implied, so we don't always have to include that. So we're just going to sum up the x's, so 4 plus 15 plus 20 plus 22 plus 15. and that gives us 76. So that's if we're just summing up the x's. Now, sometimes we sum up something other than just the x's. So like this next one, we have a squaring, and then we also have the summation. Now, if you look at number 3, we also have squaring and summation. We want to distinguish between those two. They're not going to give us the same result. We want to make sure we follow order of operations. If you remember, squaring comes before an addition. So in number 2, we're going to square the values and then add them up. So we'll square it first, then add. So we get 4 squared plus 15 squared plus 20 squared plus 22 squared plus 15 squared. Okay, so you can practice that. You can plug that into your calculator, and the result is 1,350. Let's look at the next one. So here we've got parentheses. So think about our order of operations. We always do what's in parentheses very first. That comes before even squaring. So for this one, we are going to sum or add, then square. All right, we do what's in parentheses first. Okay, well, we already figured out that the sum of the x's is 76, so we can just replace that sum of the x's with 76, and it becomes 76 squared, which, plug that into your calculator, we get 5776. Okay, so that is our just our brief overview of summation notation. Let me know if you have questions.